Hi everyone, we present 3D-VField, Adversarial Augmentation of Point Clouds for Domain Generalization in 3D Object Detection. Datasets tend to be limited representations of the world, to the point that training on KITTI gives no guarantees on the performance when deploying to the real world. This is because the domain gap can be rather large, as you can see in the images. For example, we have different countries and different vehicles, which can pose a challenge to an object detector. And even if we were to add this BDD data to the training set, there will always be out-of-domain corner cases and challenging situations that are not part of it. But can we do anything about this? Can we bridge this gap? Adversarial augmentation is a good candidate, as not only it can find the limits of a model, but it can also shorten this gap. Here, we focus on 3D object detection on point clouds, where non-standard objects like rare and damaged cars can be natural adversarial examples, creating issues to a detector, as you can see on the right image, where point pillars struggles to detect the two cars. These adversarial examples can also be artificially generated to improve the generalization to out-of-domain data. And this is what we did in this work. If we look at related works on point clouds, adversarial attacks add new points, remove them, shift them, or do a combination of these. The goal of these methods has always been hiding the objects by making them undetectable. In fact, they are all sample specific, so they overfit on each single sample, and none of them considered the 3D sensor capturing the point clouds. Our method is different. Our goal is improving generalization. We do so by first generating adversarial examples via general vector fields, which make ours sample independent. Our deformations are also sensor aware, as we only slide points along the sensor view rays. This way, we obtain a deformed point cloud. By iterating this process, we learn a vector field, which can be used when training a 3D object detector to deform objects as adversarial augmentation. To validate this, we also propose a new dataset called CrashD. It is made of synthetic LiDAR scans, and it contains realistic, damaged, and rare cars, as you can see in the video. We created various types of crashes in different intensities. The cars were then placed in a scene, like in the top right, and captured by LiDAR mimicking the ones in KITTI. This dataset is meant as an out-of-domain test benchmark for object detectors trained on KITTI or similar datasets. Here, you can see qualitative results. Compared to previous works, which were making objects unrecognizable, ours targets augmentation and preserves the overall appearance of an object. This allows us to improve generalization to out-of-domain data like Waymo or our CrashD. The interesting thing is that all models were trained only on KITTI, but thanks to our method, we got up to 59% higher AP on out-of-domain data, which shows the great impact of our strategy towards bridging the domain gap. Thank you very much for your attention. Please check out our project website for more details, and if you have any questions, do not hesitate to ask.